Hey everybody, this video lesson is on something called a neutralization reaction. Have you ever wondered what happens when you mix acid and base together into the same beaker? Well, something very unique and very interesting happens. Acid alone could cause severe damage to your body if you drank it or got it on your skin. Likewise, bases could be very dangerous as well if you somehow ingested them, eat them, drink them, or get them on your skin. But when the two come in contact with one another, they essentially eliminate the dangerous aspects of each, resulting in very easy to handle and very safe substances. And that's what we refer to as a neutralization, or to make neutral. Acids aren't neutral, neither are bases, but when they're mixed together in just the right way, they eliminate each other's dangerous properties. So a neutralization reaction is one where you mix together an acid with a base. Now if you look right here in the middle, if you take acid plus base, the resulting substance is water and salt. And water, we drink it, we need it, it's everywhere around us. And salt, depending on the acid and base, the salt could be edible as well. You just sprinkle it on your popcorn and add a nice tasty snack. This is an example of an acid and a base down here. HCl and NaOH. This one's the acid, and this one's the base. Here's the water, and this is the salt. Now in chemistry, the word salt refers to any ionic substance. This just happens to be table salt. Table salt is one of many ionic substances. Not all of them are necessarily safe to eat, but the word salt is a general term for any metal and nonmetal combined to make an ionic bond. And this has many practical applications. In fact, some of you might have experienced the phenomenon known as heartburn. If you've ever eaten food that has upset your stomach and caused you to feel uncomfortable, because you've eaten that food, you probably were given some Tums or Rolaids or something that you eat that could possibly help your stomach feel better. Now, the reason your stomach doesn't feel good is because the stomach produces acid, specifically this hydrochloric acid, or HCl. And when it produces it, it may escape the stomach and start to burn the inner linings of your internal organs. And so you feel the literal burn of the acid. Now, what you do is you eat some base. Now, not all bases are dangerous, and in low concentration, some bases are ingestible. The bases you eat are probably calcium hydroxide or magnesium hydroxide. And if you eat these, they will eliminate the acid in your stomach and reduce that uncomfortable feeling of heartburn. That is why we eat Tums or Rolaids when we have heartburn, because it neutralizes by mixing base with acid just to make harmless water and some salt. Now, other applications, if you're working in a job where there's acid or base around, and you'd be surprised by how many jobs have acid or base around. Many food industries or manufacturing types of industries have acid and base. And if there's an acid spill, you probably don't want to pick it up with your hands or clean it up with a mop or rag, because you may expose yourself to potentially dangerous chemicals. So what you do is you find some base and you sprinkle it on the acid. The base most commonly used is baking soda. You can find it in your baking cabinet or in your pantry, because you'll need it to make pancakes or bread or any sort of baked good. That base, baking soda, can be sprinkled on the acid, and it probably will bubble up and look like it's really dangerous, but actually it's neutralizing the acid so that the acid isn't dangerous anymore. Another way that this is possible to be applied is if you spill a base. And a base is used in common cleaning supplies. So if you spill some base on the floor, you probably want to neutralize it with some acid. So you'll go find some vinegar. And vinegar is an acid that you can pour onto some base and neutralize the harmful aspects of the base, because you don't want to touch that base with your hands, because it could cause chemical burns or cause some distress to your body. But if you pour some acid, some vinegar onto the base, they will neutralize one another, and then you can easily clean it up because the products are always water and salt. Now, neutralization is only achieved at a very specific time, and that time is when you have equal quantity of acid and base. If you have more acid than base mixed together, then the mixture is slightly acidic. If you have more base than acid, then the mixture is slightly basic. But if you have just the right quantity of acid and base equal to one another, then we call that the equivalence point of the mixture. Equivalence because you have equal equivalence, the base of this word is equal, so you have equal amounts of acid and base together. And at that point, the pH is 7. And in a previous video lesson, we talked about how pH is 7 is basically water. It's harmless. It's not acidic or basic. It's neither. It's neutral. Hence, another supporting statement as to why this is called a neutralization reaction, because its neutral products have a pH of 7. Now in our class, I will tell you that it's very difficult to know exactly when you have the equal quantity of acid and base together, because it's very difficult to come up with the exact quantities. Typically, you'll have a little bit more acid or a little bit more base. But in a neutralization situation, you can at least mitigate or reduce the dangerous effects of an acid, say, that gets spilled on the ground by sprinkling some base on it. You might not completely neutralize it, but you'll neutralize most of it. And if you can neutralize most of it, then it'll be more safe to clean up. The same with the base. If you spill a base, you can neutralize some of the base, but maybe not all of it. Because neutralization is a very specific situation where you have equal quantity of acid and base. You'd have to have, say, 10 atoms of acid and 10 atoms of base because they would be 100% equal. Now, in a more advanced chemistry class, which some of you may go on to take in your future academic endeavors, you may have to do a lab, and we would have done a lab if this was something that we were doing in person, where you would mixing acid and base together and monitoring the pH to kind of see where and when the equivalence point has been reached. But that is not something that we are able to do during distance learning. But that's something that as scientists we can monitor using very interesting apparatus or very interesting instruments. There are different things that you can use to measure the equivalence point or the neutralization of the reaction. You can use a tiny strip of paper that you dip in that changes color depending on the pH, or you could use a special dye that changes color when the pH goes from, say, acidic to basic. The color of the solution changes, which is kind of a cool thing to see. The last thing that you could use would be a digital probe or something that you stick into the solution that tells you what the pH is exactly. Almost like a thermometer tells you what the temperature is, a pH probe tells you what the pH is. So I jotted these down here at the bottom of this slide because I think that this would make for an excellent quiz and test question. The 3 ways to measure the pH or to measure the equivalence point would be pH paper, a color-changing dye, or a digital probe. Here's what pH paper looks like. And basically what you do is you rip off a little strip, because inside this little plastic case is a roll of paper, and you unroll it almost like toilet paper, and you rip it off, and it's really small. It's about the size of your pinky or the width of your pinky finger, and then you dip it into the solution, and it magically, actually it's not magic, it's science, but it changes color, and you compare it against the colors on the side of the container to tell what the pH is. And if you dip it in and it's in the orangish red area, it's going to be acidic. If it's darker, greens and blues, then it's going to be basic. But if it's nice and green, then you know you're at a pH of 7 or about a pH of 7. The next way to tell whether you've reached the equivalence point is using a color-changing dye. And these are really cool because they actually change color, and you'd be surprised. Another thing that looks like magic but is really not. And so you've got a solution that's acidic, and it's got a pH of 5, and it'll stay clear. And whether or not it's 6 or 5 or 4 or 3 or 2 or 1, the acidic pH will stay clear. But as soon as you add a little bit of base to that acid to make the pH go over 7, it will change to pink, just like this. And you'll know that it's basic at that point because the color goes from clear to pink. It's pretty wild. And if I was able to show this to you, you would be amazed. Trust me, you certainly would. And the final way that you would be able to tell whether or not you're at the equivalence point when you're mixing acid and base together is using this pH probe. And I grabbed this picture off the internet. But basically it's got a digital computer, and out of the computer are little wires that connect to the probes. And now the probe could be this or this. And these two probes go into the liquid that tell you what the pH is inside the solution. So let's say you start with an acid, and so you put these probes into the liquid, and this will read 5 pH. And then you add a little bit of base, and the pH will go up. You add a little bit more base, and the pH goes up until you get to exactly 7, then you stop adding base. Then you know you're at the equivalence point, where you have equal quantity of acid and base in the beaker at the same time. So these are the 3 ways that we use to determine the equivalence point in a neutralization reaction. Well, that takes care of this video lesson. Thanks for watching.